Hi, Algebra 2. This is Unit 3, Lesson 6, and today we're going to talk about piecewise linear functions. This is something that you did back in algebra as well. So a piecewise function is a function that's defined on a sequence of intervals. There are going to be different equations for different portions of the domain. So I just have 4 examples across the top here. You don't need to write any notes or anything. I just wanted to show you what they might look like. So you can see this first one on the left. For the domain where x is less than or equal to -1, then I'm going to use the function f of x equals x plus 2. That's the one that's right here in blue. So you see that the domain includes -1, so I have a closed circle there, and then it's anything less than that number, and I'm using the function again, x plus 2. And then I have all the values of the domain between -1 and 1, but not including those numbers. That's just f of x equals 1, so that is going to be a horizontal line. And then the last part of it is all the numbers that are greater than or equal to 1 is my domain, and that function is f of x equals x squared. So you see we have this like little tiny part of that parabola right there. So that's a piecewise function, right? There are different equations for different portions of the domain. The next one over, where all the x's are greater than or equal to 1, I'm going to use the function x minus 1 squared. So that's this right here in blue. Okay, I'm including the 1, so that's why I have a closed circle at the 1. But yet for the second part of it, where x is less than 1, notice I'm not including the 1. So look at that open circle right there. And for that one, I'm using the function f of x equals x plus 3. So again, my domain are all real numbers, my range are all real numbers. And you have to pay attention to whether you're including that number or not in the domain, hence the closed circle and the open circle. For the next one over, I have 3 different ones. So when x is less than -2 or greater than or equal to -5, all right, at g of x equals 0, that's this red little portion right here. All right, and the next one, where x is between 1 and -2, I'm including the 1 and I'm including the -2. I'm using -x squared plus 4. That's this guy right here. And then for the last one, where x is less than or equal to 5 or greater than 2, see I'm not including the 2, so I have that open circle right there. And then I am including the 5, so I have a closed circle, and I'm using that right there. Okay, so my domain are all the numbers from -5 to 1 or from 2 to 5. But notice I have a gap in the domain. There's nothing between 1 and 2. All right, well, I'm including 1. I'm not including 2. So I'm including the 1, so I have that bracket right there on the 1. All right, I'm looking at this right here. Let me see if I can get a color to highlight. Notice there's a bracket right here on the 1 because I am including the 1, but there's a parenthesis at the 2 because the 2 I'm not including. The range goes from -2 to 4. The lowest number on the y's is -2, which is right here, and the biggest number is 4 right there. So I'm just also besides these piecewise functions, we're talking a little bit about domain and range. In that next one, the last one on the right, when x is greater than or equal to 0, I have 2 to the x, so that's this one right here in blue. And then when x is less than 0, so notice I have the closed circle, it's x to cube, so that's this part right here. All right, so my domain are all reals, even though there's an open circle here. At 0, there's a closed circle there at 0, 1. So I am still including the 0. So my domain are all reals. My range, though, has a gap. So I go from -infinity to 0. I'm not including the 0 because there is a open circle. So notice there's a parenthesis at the 0. There's a gap between 0 and 1. I am including the 1, so I have a bracket at the 1. And then it goes forever and ever, and that is infinity. Okay? So if you're looking at example exercise 1, we'll do this one together. Consider the piecewise linear function given by the formula f of x equals x minus 3. So for all the values of x that are less than 0 or greater than or equal to -3, I'm going to use, let me get my highlighter here, let me use yellow. I'm going to use this one right here, x minus 3. So basically, when x is negative 3, I'm going to plug in negative 3. Negative 3 minus 3 is negative 6. When x is negative 2 minus 3 is negative 5. When x is negative 1 minus 3 is negative 4. Okay, and when x is 0 minus 3 is negative 3. Now I'm going to do this because I'm actually not including the 0. The value would be negative 3, okay, but I'm not going to include it because 0 is actually in this next piecewise function. So I want x is greater than or equal to 0 or less than or equal to 4. All right, so I'll do that one in a different color. So when x is 0, 1/2 times 0 plus 4 is 4. When x is 1, 1/2 times 1 is 1/2 plus 4 is 4.5. When x is 2, 1/2 times 2 is 1 plus 4 is 5. You can see they're just going up by 0.5 each time. 1/2 times 3 plus 4 is 5.5. And 1/2 times 4 plus 4 is 6. So I should plot those. So I got 0, 4, which is right here, and I am including that point. 1, 4.5, 2, 5, 3, 5.5, and 4, 6. All right, so I'm doing this. And let me go back to my other color for the other one. I think was I using purple? So negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6 is included. Negative 2, negative 5, negative 1, negative 4, and 0 is negative 3, but I'm not including that, so I'll have an open circle there. Okay, so I created my table and I graphed it. So just to repeat, this is not included because notice I'm not including the 0, so that's going to be an open circle. And this one, I am including the 0, so that's going to be a closed circle. So I did write both of those values in my table right there. And then I want to state the range. So the range are the y's. So I'm looking, the lowest most y is right here, and that is at the point negative 6. I am including negative 6. Now I'm going to have to write two ranges separately because there is a gap. So I'm going to negative 3, but I'm not including the negative 3 because there's an open circle right here. All right. And I also have my other range for my other line is going from 4 to 6. And those are included, so I will use brackets. All right, sorry about the barking dog. We're just going to ignore that. That's my little puppy, Riley. All right, so exercise 2. We have the function f of x is shown graph below. Write a piecewise linear function for the write a piecewise linear formula for the function. Be sure to specify both the formulas and the domain intervals over which they apply. All right, so I'm going to make my big set of brackets right here. All right, I have 3 different pieces to this. The easy one is this piece right in the middle. So that horizontal line is the equation y equals 4. So I'm just going to put 4. And that occurs from all the x's from negative 2 to positive 3. All right, so I got x, and that goes from 3 to negative 2. Now you can see, since it's a closed circle, I could have put an equal sign also with the 3, okay? But the 3 is also included, let me get a different color, in this next one here. So I decided to put the equal sign there. It would have been fine to do the equal sign with either one, all right, because it's the same value at both of them. There's no gaps or anything like that. And this one is going till, that's 1, 2, 3, 4, 5, 6. I am including the 6. Okay, and then my first one, I'll grab a different color. I'll grab green. Maybe I should have started with the first one, but I felt like that horizontal line was the easiest one to do. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is from negative 8, and I have to include that one, to 2. Now, since I had the equal sign in the middle with a 2. I'm not going to use the equal sign right here with that negative 2. But again, that could have been changed around. All right, now I need to write an equation of these lines. I need to know the slope and the y-intercept. So what you can do is you can just extend these lines to find the y-intercept. You can see my slope right here. If I start right here, I'm going 1, 2, 3, up 3 over 2. See this? Up 3 over 2. So my slope is 3/2. So I can keep on going up 3 over 2. All right, so you can extend that line. It's not really a line, but I really need to know my y-intercept. So 1, 2, 3, 4, 5, 6, 7. So my slope is 3/2, and my y-intercept is 7. Because now my equation is really easy to write. 3/2 x plus 7. And I already have the f of x equals over here, so I don't need that. And then I'm going to do the same thing for my last section, because I already did the middle one. I can see what my slope is. So I am right here. See how I'm going up 2 and to the left 1, up 2 to the left 1. My slope is -2. And I'll keep on doing that. Up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. So I'm sort of really off the graph right there. That has a y-intercept of 10. Okay, so my equation is -2x plus 10. So I have my equations and I have the intervals. Piecewise functions can be challenging algebraically. Sometimes information that we find from them can be misleading or incorrect. So if we're looking at exercise 3, consider the piecewise linear function g of x. From when x is less than 2, it's 5 minus x, and when x is greater than or equal to 2, it's 1/2 x plus 2. Determine the y-intercept of this function algebraically. Why can a function have only one y-intercept? So to find my y-intercept, that is g of 0. Now which equation am I going to use? I'm going to use this one right here. Let me just grab the yellow. I'm going to use this because this is where x is 0. The x is less than 2. I use 5 minus x. So I'm going to use 5 minus 0 equals 5. Okay? It can only have one y-intercept because there's only one output for an input. So it can only have one y-intercept because only one output for an input. Okay, and then they want me to find the x-intercepts of each individual linear function. So let's do the first one. So 5 minus x equals 0. I'm finding the x-intercept now, so that's when y is equal to 0. I'm going to I'll move this x over to the left, and I get x is 5. That's one of them. So I was doing this one right here, and now I'll grab another color. I'll do this one right here. So I'm going to do 0 equals 1/2 x plus 2. I'm solving for x, so I'm going to subtract 2. -2 equals 1/2 x. And I'm solving for x, so I'm going to multiply by 2 over 1. X equals -4. That's my second y-intercept. All right, let's do a little graphing. All right, so let's see. Graph the piecewise linear function below. So the first one has a y-intercept of 5, 1, 2, 3, 4, 5, and it has a slope of -1. So basically it is down 1 over 1, down 1 over 1. It's only going to 2, and then I can just go up 1 over 1, up 1 over 1. This goes forever and ever. Okay, now I'm not really including this right here, so that technically should be an open circle because I don't have an equal sign with that 2. But let's look at the next one. I have 1/2 x plus 2. So 1/2 x plus 2. So this has a y-intercept of 2. I'll do this in another color. So this has a y-intercept of 2, which is right here, but I'm not starting but it's 1/2, so I would go up 1 over 2. There we go. There's my starting point. Up 1 over 2. Up 1 over 2. So I can technically, I'm starting right here with a y-intercept of 2, but that point wasn't included, so I'm going like this. Okay. Now here's a question, D. Why does your graph contradict the answers you found in part B? In part B, I said that there were x-intercepts at 5 and -4, and this graph is actually never touching the x-axis. The graph contradicts what we found in part B because it has